In this video, I'll be setting up an Apex rig, and this rig will be set up to use BlendShapes. This will be done using the Apex AutoRig nodes. This is going to be a very basic rig, but it will give an idea of how this kind of setup works. I'll begin by creating a tube. I'll shift this tube so that its base is at 0 on the y-axis. I'll close the end caps, and I'll lower the radius. I will need to deform this tube, so I'll increase the rows and columns. I'll need a skeleton for this rig, and for this I'll use a skeleton node. In the front view, I'll draw out 4 points. I'll then duplicate this node in order to create a guide skeleton. This skeleton will have a separate joint, and this joint will be for our controls. So I'll select this joint and I'll set the mode to modify. The name for this joint will be renamed to controls. This gives me 3 elements for my rig. I have my mesh, I have my skeleton, and I have my guide. Next, I'll need to add weights to the mesh, and for this I'm going to use a joint capture by harmonic node. The first input will be set by the mesh. The second input will be set by the skeleton. In this case, I can also get away with setting the third input as the controls, and this is because these joints have exactly the same names as the skeleton. Normally we should drive this with the skeleton as well, but this will just simplify this network. I can add a pose node to the third branch so we can test this. I'll then get a bone deform node to test the mesh. The first input will be set by the mesh. The second input will be set by my default skeleton. The third input will be set by the animated skeleton. Although in this case this is actually my guide. I can attach a pose node to the third branch to test this. In this case I'll attach it after I've added the weights. I can then test, and my mesh is deforming. Since the deformations are working, I'll make some updates to the geometry. The first of which will be to add local transforms to my guide and skeleton. I'll do this with the compute transforms node. I'll set this node to convert world transforms to local transforms. The Apex AutoRig node will require local transforms, and this will ensure that we have them. I'll attach a copy of this node to both my skeleton and my controls. Next, I'll add normals to my mesh, and I'll do this with the normal node. I'm going to be deforming this mesh, and more accurate normals will give me more reliable deformations. I can then perform these deformations, the first of which will be performed with a peak node. I'll then use a point jitter node, and I'll add a third deformation using a mountain node. All of these will be set to the mesh by connecting them to the normal node. For the peak, I will expand the mesh slightly. The jitter will need a very small value, so I'll set this to 0.01. I'll leave the mountain node at its default values. The results of each of these nodes will be used as blend shapes. To do this, I'll first convert these into packed geometry, and I'll do this by connecting all of these nodes to a merged packed node, and this will convert all of these to packed geometry at the same time. I'm going to rename the deformers. These will be peak, jitter, and mountain. The next thing that I'll do is add a name to the mesh. I'll do this with the name node, and this will be a primitive attribute. I'll give this mesh the name pole. I can now add the blend shapes to the mesh, and to do this I'm going to use the character blend shapes add node. The first port will be set by my mesh. I want the mesh and the blend shapes to be one contiguous piece of geometry. Generally you'll want to remove any groups so that you're guaranteed to only have a single piece of geometry. In this case this mesh is basic, so there is only one piece of geometry, and here I can specify the name of the geometry, which will be pole. This should set up the blend shapes, but we will not be able to use these blend shapes. This is because we need to add a value to the skeleton. Specifically, I'm going to add this to the controls branch, as this is also currently functioning as the animated branch for my skeleton. I'll add these attributes as detail attributes, and this will be done using an attribute wrangle node. Within this node, I'm going to add 3 attributes. I'll call these peak, jitter, and mountain. All of these will be set with a float channel using the CHF function, and this will give us a slider, and this slider will be called peak. I will then have a float slider for the jitter, and I'll call this jitter. Finally, I'll have a float value called mountain. These should all be float attributes, so they should have a prefix of f@. I can then generate sliders for these parameters. The names which I've used for the attributes here are important. These names should match up with the names for my packed geometry. The names in the merge pack node aren't correct, so I'll need to regenerate them. And these are the names which we'll use to generate our attributes. It is, however, more important that these names match up with the attributes for our blend shapes. To see these attributes, I'll be looking at the geometry spreadsheet, and I'll be looking at the primitive attributes. Here we should have 2 attributes for the blend shapes. These will be the blend shape channel and the blend shape name. The values that I've created for the sliders must match the values in the BlendShape channels, as this is how the BlendShape channels will be registered, and this information is actually necessary for exporting the BlendShapes, and it should be part of the animation branch, although the animation branch should actually technically be set by the skeleton. However, this will work in this case. Once again, as I stated previously, the BlendShapes themselves are just packed geometry, so we can extract them using an unpack node. So essentially, this is packed geometry, where we have a reference to the channel which is going to drive the BlendShape, and the packed geometry itself, which is the BlendShape. To display the BlendShapes, I use a character BlendShapes node. This is a node which you must be very careful with, and I wouldn't necessarily use it as part of a network. I would only ever really use this after a network. You should note that you cannot export geometry when using this node, as this node will delete any BlendShapes that are part of the mesh. I can now attempt to test the shapes, but these will not currently work. In this case, I've forgotten to update the type in the attribute Ruggle node, and this should be a detail attribute. I should now be able to use my shapes. I should have a peak, I should have a jitter, and I should have a mountain deform. So this gives us our basic skeleton and BlendShapes, and this is essentially the standard KineFX setup. However, I'm not going to be using this for KineFX setup, instead I'm going to be using it for an Apex setup, so I can delete the character BlendShapes node, as well as the bone deform node and the pose node, and instead I'm going to pass the output of my mesh into a packed folder node. I connect the three outputs of the joint capture biharmonic node to the second port of the pack folder node. In the pack folder node, I can update the names. The first element will be base. The type of this element will be shape. This will be followed by the skeleton, which will also be called base, and this will have the type skeleton. The final element will be called guide, and this will also be a skeleton element. So this will give me the pack geometry, and I can now begin building a rig with this. In this case, I'm going to use the AutoRig nodes. So I'll add an AutoRig node and I'll connect the first input to my pack geometry, and I'll begin this rig by setting the component to FK transform. This is generally where you want to start when creating an AutoRig network. The FK transforms will generate parts of the network that we will need for later nodes. I do get a warning here, and this is because of the naming of my guides. This is because there is a mismatch between the names which I've added to the skeleton and the default names within the FK transform component. In this case, it's to do with the spelling of guides. I'll update my pack geometry, and instead of guide.skeleton, I'll have guides.skeleton. Now that the names match, this will work correctly. A lot of this is working because of my naming of the ports. If you want more specific naming, you will need to update the names in the component. There are a number of changes which we could make to the FK controls, but I'm not really going to change anything here. An easy example would be the shape. I could change this from ball to box. Or I could use an even more obvious control like the cross control, although this control doesn't really matter. I'll change this back to a ball for the moment. We should now be able to test the animation, although this will not really make much difference, and this will only show me a skeleton. To see what's being created, I'll need an unpack folder node. The unpack folder will allow me to see all of the pack geometry which we're generating, and currently we'll be generating 4 primitives. 3 of these are the geometry which we created within the pack geometry folder. The fourth one is the rig. The rig is our final Apex rig, and this is being generated by our FK Transforms node, and the rig is generally what we want to examine when using this node. Here we'll be generating a number of transform objects, and these will be named off the points. And these will be connected to a set point transforms node. They will also be connected to the input. We can tell that these are being generated from the guide network, as one of the transform objects is for the control joint, and this is separate from the rest of the network. I can now return to the AutoRig network, and the next thing that I'm going to add will be the deformation. This is slightly counterintuitive, as the bone deform will actually occur last in our network, and it will always be one of the final things which will occur in the main rigging pipeline. This deformation will need to occur after the BlendShapes. The BlendShapes should always be processed before deformation, and this is because the BlendShapes are an offset from the base geometry, so you shouldn't change the base geometry before making that offset. When using the auto-rigging nodes, however, we do actually want to make the bone deformation reasonably early, and the reason for that is these nodes are essentially scripting a rig, and because of this there are things which we need to generate for other scripts, and the most important nodes which we need for other scripts are our bone deform and our set point transform nodes. So I'll connect the second AutoRig node, and this will be set to bone deform. I'll unpack the adjuster network and we can look at the result. This node will actually add 2 nodes, and these nodes will be colored purple. The most important one of these is the bone deform node. This node will begin with 3 geometry inputs, and this will store our rig. The third one of these inputs is connected to the set point transform node, and this branch is dealing with the skeleton. The second input will be set by the mesh for the rig. This branch begins by having the geometry cached in a value node. Essentially, this will be our rest geometry. The first branch will be set with the original mesh, and this will be set directly from the mesh input. Any point deformations that we make will usually occur on this branch. So the set point transform node will update the skeleton for the animation, and the bone deform node will deform our mesh based off the animation of the skeleton. Generally, when using the AutoRig node, we do not need to make many changes when updating this network. Here I'll leave all of the parameters exactly as they are. I've now set up the basic network, and I can add the blend shapes to this network. So I'll get a third AutoRig node, and I'll connect this after the bone deform network. This node will be set to use a blend shape component. This setup should work automatically, so I'll examine the unpacked network. As previously, our final node will be the bone deform node, and this will have the skeleton set by the set point transforms node. We'll then have a node which contains our blend shapes. The bone deform is connected to the second input, and the blend shapes is connected to the first input. So what we will require for the blend shapes is a point transform for the skeleton, as well as a bone deform for the deformation. Without these nodes already being part of the network, the blend shapes cannot be connected correctly. The blend shapes also must occur before the deformation of the skeleton. Once again, the reason for this is the blend shapes are offset from the base mesh, so this offset should be calculated before deformation, as changing the base mesh will change the relationship of the base mesh to the offset. So once again, first I'm adding the FK transforms in order to get the point transform added. I'm then following this up with the bone deform node to make sure that the bone deform is part of the network as well. The bone deform should be created after the set point transform has been added to the network, otherwise the bone deform cannot be connected properly. And after this we are able to add our blend shapes, and this is because we now have the bone deform available. If we look at this node, we'll see that we have the option to set a bone deform node manually. If we do not have the bone deform in the scene, this will not connect correctly. So if I was to change the name to a random value, we'll see that we run the risk of not having the blend shapes connected. So now we should have a basic setup with FK controls, with bone deformation, as well as blend shapes, and we can set some of the options on these blend shapes. So there are 3 options here. They're the settings. This is essentially the name of the mesh elements that we need. We can also specify the bone deform that we're going to connect to here. This will be followed by the parents, and this is primarily used for the controls. We also have a shape option which can be used for controls. The shape option will specify the display of the controls, where the parent will specify where the controls are generated. So in this case, I've created a joint called controls, and I can specify that here. I can then go to my animate node, and I can activate the animation. When I activate the animation, we should see that we have 3 control objects, and we do have control over how these objects are created. So if I go back to the Parents tab in the AutoRig node, I can adjust the control offset option, and we can see that this shifts the position of these controls. These, however, are not linked with my controls, and that's because I've spelled controls incorrectly. This is case sensitive, so we should have a capital C. And now the controls for the shape will be adjusted relative to my controls joint. I can, of course, specify the shapes for these controls. For example, I can change these into circles. This shape will apply to all of the controls which we're generating. We can, of course, leave this parent value empty, and we can add parent values for each control individually. This will be done with the parent custom controls. The first option here will be the control which we're setting, and this will actually be the name of the blend shape. For example, I can specify the peak blend shape. Once again, I can specify a parent for these controls, and in this case I'll place them under the controls again. I can then have an offset. I'll specify this as 0.1 in X, as well as 0.1 in Y. I've once again forgotten to capitalize controls. I should now be able to move the control joint, and the peak control joint should follow this. I should be able to do this for each of the controls, so I can add a second operation. The blend shape here will be mountain. I'll set the parent here to be 0.3. I'll give this an offset of 0.1 in Z. This is how the control parenting with the interface will work. I can now test this. I'll begin with the mountain control. This will give me some basic but rather ugly deformation. I can then manipulate the bones, and the deformation should follow with the bones. By default, the abstract controls will allow us to overshoot the shapes easily, so I'll try and lessen this deformation. I can test my jitter deformation, and this is also working, and the peak deformation is working as well. So that's basically what's required to get blend shapes working with deformation using the Apex AutoRig nodes. We can go through what's needed again. We'll start by getting our geometry. This mesh should have a mesh name and should be a single contiguous piece of geometry. We'll then need to create our shapes, and these shapes will be stored as packed geometry. The blend shapes can then be added to our mesh. This will be stored in two attributes, which will be the blend shapes name and the blend shapes channel. We'll then need to add detail attributes to our rig, which will drive the blend shapes, and the names of these attributes should match up with the blend shape channels. This will give me the basic setup that I need for KineFX rig. I will then use this basic geometry to make packed geometry for an Apex setup. After this, I'll need a network which will add a set point transform node to the network, and for this I'm using an AutoRig node with an FK transform component. This is the easiest node to use if you want to have all of your controls added to a network, and this will also add and connect the set point transform node as well. After this, I'm going to use an AutoRig node to add a bone deform to this network. The bone deform node is usually going to be the final node for the basic rig setup. This will give me the basis of my rig, and everything else is actually going to be connected between these nodes and the input. In this case, I'm going to be connecting the blend shapes, and I'll do this with an AutoRig component again, and this component will be the blend shape component. This will allow us to add the blend shapes to the network, but it will also allow us to set up basic controls for the blend shapes. It will give us options for the display of those controls, as well as the placement of those controls. This node does have the requirement that we do find a bone deform node, and that this bone deform is named correctly. Apart from that, the main requirement is to specify the names of the skeletons, the shapes, and the guides. So we've generated the network and it has guide shapes added to it. We can now look at the guide shapes and look at how these are actually being set up and how they're actually working. The main parts of the blend shape setup will be a subnetwork for the blend shapes, as well as a set of abstract controls. This abstract control node here is primarily for the display of the abstract control, and the connection for this port is connected to both the abstract control port, as well as the ports to the subnetwork for the blend shapes. Both the abstract control and the subnetwork have a prefix, and this prefix is ball. This prefix is being used within the subnetwork as well. This prefix has no relevance to either the character or the mesh, so I do want to change this. So I'll return to the top of the network and I'll work on the abstract control. There are two fields in the component parameters which are located before the tabs. The first of these is called prefix, and this is what is currently creating the prefix for the blend shapes. I will change this to pole. I can now look at the updated rig. The abstract control now has a prefix of pole and has the name pole blend shape peak abstract. I also have a jitter abstract control, which has the prefix of pole, and now I also have a transform object for my jitter blend shape. This is being used because I'm positioning my controls in 3D space. This transform object also has a prefix of pole. These abstract controls are connected to the input ports, and the input ports which they are connected to are also driving our subnetwork for the blend shapes. I will now enter the subnetwork. In the subnetwork we have 4 nodes. The first 3 of these are setting attributes, and these are setting detail attributes. The first of these is setting the peak attribute, and this attribute is matching the detail attribute that I added to my rig earlier. I should however note that these attributes do not really have a practical influence on the Apex rig, as the set attribute nodes in the blend shapes are actually creating new attributes on the skeleton. Those are doing exactly the same thing as these attributes, but they are technically being created as new attributes. These attributes that I'm creating within this attribute wrangle node are not technically needed for the generation of the blend shapes. I'll return to the blend shapes, and once again we're setting the attributes, which are the peak, the jitter, and the mountain. And then we have our blend shape nodes, which is actually updating the blend shapes. And this node is the KineFX character blend shapes core node. We have 2 inputs for this node, and these are geometry inputs. The first of these is taking the geometry for the mesh, and this is the mesh which should contain our blend shapes. The second is taking the geometry for our skeleton, and this is adding detail attributes to the skeleton. These values are being set by the inputs. These are the same inputs which are connected to the abstract controls, so these inputs are being driven by the abstract controls. This node will then have 2 outputs, which will be the main mesh geometry, as well as the skeleton geometry. The skeleton geometry will need to be connected to a set point transform node, which is updating the skeleton, and the mesh geometry will need to be connected to a bone deform node, and this will allow the skeleton to update the mesh. And this will give us the basic setup that we need in order to have skeletons working in concert with blend shapes in Apex using the AutoRig nodes.